We're on.
Good evening, everyone. Welcome to the 24th Annual Barnegat Bay Environmental Educators Roundtable. My name is Becky LeBoy. I'm the Education Outreach Specialist with Ocean County Soil Conservation District. The district has been effectively coordinating and implementing the Barnegat Bay Environmental Educators Roundtable since 1997. The Roundtable provides professional development opportunities for both school teachers and informal educators. And the theme for this year's Roundtable is Inspiration for a Jersey-Friendly Schoolyard. The Barnegat Bay watershed is a great place to live, learn, work, and play. It's up to all of us to keep our soil, water, and other natural resources clean and maintain healthy habitat for wildlife. A Jersey-friendly schoolyard can offer an inspirational space for teaching and learning about natural resources and learning about the direct impact that human behaviors have on the health of our community. 2 weeks ago, my colleague Karen Walzer and I, Karen is the Public Outreach Coordinator with the Barnegat Bay Partnership, presented the first webinar in our series of 3 called Planning a Jersey-Friendly Schoolyard. And if you missed this program, you can find it on the Ocean County Soil Conservation District YouTube channel. And last week, my colleague Caitlin Gannon, Education Coordinator for Jacques Cousteau National Estuarine Research Reserve, presented her program called Why Jersey-Friendly Schoolyards? Understanding the effects of fertilizers on eutrophication and coastal acidification. And that was the second webinar in our roundtable series of 3. So tonight, thank you for joining us for our third and final webinar in our Environmental Educators Roundtable series. If you have any questions for our speaker this evening, please enter them in the chat area. So please welcome Dr. Steve Urjo of Rutgers Cooperative Extension, who will be presenting How Does Your Rain Garden Grow? Steve, thank you so much.
Oh, no problem, Becky. Thank you for having me. And thank you, everyone, for joining us tonight. Really excited to talk to you guys about rain gardens and what resources are available for you to actually get one started at one of your schools. First and foremost, let me just do a quick introduction for myself and for Cooperative Extension. As Becky said, my name is Steve Urjo, and I am the County Environmental Agent for Ocean and Atlantic counties, primarily housed within Ocean County. Do a lot of work in the Barnegat Bay watershed, dealing mainly with water resources and watershed protection. So that's why I'm here today to talk to you guys. But Cooperative Extension is part of the Rutgers University system. The extension offices are found in all 21 counties of New Jersey. And we work kind of as the go-between between the university and the research and the education that happens there to the rest of the state of New Jersey, primarily within the different counties that we work in. So we'll take what's learned in research at the university and take that science-based education and bring it out to the general public. We'll bring it to municipalities. We'll bring it to other educators like yourselves. And we work primarily in a few main areas. We do 4-H youth development. We also have our Rutgers Master Gardener program. Usually 4-H and Master Gardeners are how people know about Cooperative Extension. But we also work in natural resources protection and environmental stewardship. For Ocean County, we are focused also on marine fisheries and aquaculture. We also deal with agriculture, horticulture, but we also have nutrition and wellness education as well. And you can see our website at the bottom of this slide. So if you'd like to get more information on the Cooperative Extension of Ocean County and what we do, that would be your kind of gateway to do so. So just a brief introduction of Cooperative Extension and who we are. So what I'm going to do today is I'm going to talk to you guys about rain gardens. I'll do a brief introduction on rain gardens, what they are, why they're important, and then also talk about some of the steps and some of the planning that you'll need to go into actually installing, designing, installing, and maintaining a rain garden. And then primarily what you guys would be interested in is going through some resources that are available for rain gardens themselves, but also some that are particular for schools and what they can use in terms of lesson plans and help for best practices to actually get a rain garden installed on your property. So we can't talk about rain gardens without talking about rain first. So we're going to talk a little bit about water. And New Jersey is considered a water-rich state. And by that, we mean that it gets a lot of rainfall each year. So the average is about 45 inches per year. It varies from 42 to 48 inches, depending on what part of the state you're in. But generally, it's about 45 inches of rainfall each year. Some other parts of the country, like Southern California or the Southwest, get anywhere from 5 to 10 inches of rainfall for total for the year. So you can see how we could kind of be seen as kind of having abundance of rainfall. But even though we have this kind of abundance and this replenishment of our water resources through rainfall, we're also a state that's very densely populated. There's over 1,200 people per square mile within the state of New Jersey, and each one of those people is using about 70 gallons of water per day. There's roughly about 9 million or so people in the state of New Jersey, so that's about 630 million gallons of water per day that are being utilized. And in the summertime, primarily from April through October, which is also the growing season for New Jersey, if you include outdoor water use and irrigation, that jumps up to over double that amount to 155 gallons per day. So water is a resource that we need to actually, consume and thrive and survive with, because we all need water to survive. But it's also used in agriculture and maintaining our outside landscapes and manufacturing processes. So we have materials to utilize every day. And so that's where this kind of consumption of 70 gallons per day comes from. So in addition to just the everyday things, even in the summertime when we're doing outside irrigation, outdoor watering, that more than doubles the amount. So you can see that we may need to conserve some of this water. And one of the ways you can do that is through a rain garden, which I'll get to in a little bit. So this is just kind of to show you that sometimes, even though we're using all this water and we have all this rainfall, there are times when we don't have as much water as we need on a daily basis. So we'll run into a situation like a few years ago, about 5 or 6 years ago, where we had some drought watches that were issued for southern New Jersey for Ocean County. And also showing that, with more people coming into the state of New Jersey, obviously there's more of a need for water to keep those people alive, and also for the different processes that they need every single day to survive in terms of agriculture, et cetera, et cetera. And this map on the left part of the slide shows kind of where that water is coming from and how much is being used. And the bigger the pie chart, the more water is being consumed. And you can see that, the headline at the top of the slide that says we're a thirsty state, you can see that, we are, simply by the number of people that we have, the amount of water that we use on a daily basis, but also, the sources that we're getting it from, whether it's groundwater, rivers, the Delaware River, or from reservoirs. So you can see that water is a necessary resource for us to survive, but at times it can kind of not be available for us to use, whether it's naturally happening or basically being overused. But the converse of that can be, just a few years later, or a few years ago in 2015-16, we had drought conditions. And then in 2018, it was considered the wettest year on record for most of New Jersey. So we went from a situation where we had a famine situation of water to a feast of water. So we went from having these major droughts where there wasn't enough water to go around and people were under a drought watch, to excessive flooding and the wettest year on record. So you can see there's this variability in where our water is coming from and being replenished primarily through precipitation and rainfall that, would enable us to have means to save water when we have the water coming down, and also reduce water and flooding in particular when we have an excess of it. So rain gardens are a good way to kind of do that and to help the landscape plants survive, and also to help replenish our waterways and especially our groundwater. So you can see that there's just kind of this variability, not just in terms of the amount of people that are using water and how much is used throughout the year. Sometimes it's 70 gallons per day, sometimes it's 155, but also in the natural variability of having no water and then having an excess amount of water. And what I'm really talking about here is I'm talking about changes to the water cycle. And there are different components to the water cycle. Rainfall and precipitation is one of them. I remember it through the acronym of PIES, P-I-E-S. So that's precipitation, infiltration, it's evaporation, and then it's surface flows and surface runoff. So PIES, precipitation, infiltration, evaporation, and surface flows and surface runoff. So precipitation is what I've been talking about the past couple of minutes. It's the rainfall, the snowfall, the snow melt that comes off the land surface. It's how we get basically the biggest input of water back into the environment is through precipitation. Infiltration is the movement of that water from the atmosphere into the ground surface. So going from the atmosphere as precipitation and moving onto the land surface and going back into the ground as infiltration. If it doesn't get absorbed into the ground through infiltration, it'll probably become surface runoff and it'll float along the surface and go along the land surface. So that's the surface runoff portion, the surface flows I mentioned. This will move it through rivers, creeks, lakes, get stored in ponds and lakes, and eventually out to Barnegat Bay and then the Atlantic Ocean for our region. And then evaporation is the loss of the water from the land surface, whether it's held up in a lake and stored there or in Barnegat Bay, or if it's just, in the soil, it will evaporate through, the heat of the sun back into the atmosphere, form clouds. The clouds will build up enough moisture, they'll get heavy enough, and they'll, through gravity, be pulled back down to the earth through precipitation and then infiltrate in the ground or become surface runoff or actually evaporates. So the whole cycle goes through itself over and over again. And one of the things to keep in mind with the water cycle is it's really driven by two forms of energy, and that's solar energy. So that's the heating up of the water to evaporate it back to the atmosphere. And then also gravity. So you have gravity pulling down the heavy water that's in the clouds as precipitation. You also have it pulling it through the soil, through the infiltration processes, and then also moving it along the surface of the landscape as the water goes from a high point to a low point. So you have these natural processes that can kind of go on and cycle continuously, basically without any human interference. But the problem is that there is human interference. So there are all these factors that go into affecting the water cycle and how much rainfall we're going to get, how much evaporation is going to happen, how much infiltration is going to occur, and how much surface runoff we're going to have. And that's primarily weather and climate. Obviously, as I showed you before, some years are wetter than others, some years are drier than others. This past winter, we had one of the snowiest winters on record. So we had a lot of snow melt. So there was extra water in the wintertime, which we hadn't had in a couple of years. So you can see weather can affect that because primarily, it is part of the water cycle in terms of the precipitation that falls. So the more rainfall you get, the more precipitation. The warmer days you have, the more evaporation, possibly less rainfall. So that can change the different proportions of those different parts of the water cycle. The land use and what we do to the landscape can affect how quickly water infiltrates into the ground, how much storage there is, how quickly the surface runoff will flow and cause flooding, etc. And the same with vegetation and soil type. So vegetation will actually, the plants will take up some of the water. Vegetation will also physically be a barrier to slow down water flows. And actually, if you have slower water, you have more of a chance for it to get absorbed back into the soil. And if the soil type is conducive, like we have in Barnegat Bay watershed, it's mostly sandy soils as a general rule. They're pretty absorbent, so the soil type will tell you whether or not you can absorb a lot of the water back into the landscape and back into the soil and the groundwater, and then have it stored there to eventually get to either an aquifer that can be utilized for drinking water or eventually seep its way back into the bay or another water body. And then those water bodies themselves can actually affect the amount of water that's moving through a water cycle. So if you have these big storage areas of ponds, lakes, reservoirs, eventually to the bay, for example, or lots of streams and rivers, that water can actually be held in those systems if it's a pond or a lake or a reservoir, or it can actually be conducted from one area to another through, say, a stream or a creek, etc. So the amount of water that you have in an area is really going to be, determined by the water cycle, but then the water cycle itself will be determined by these different factors that can change the different amounts of each of those component pieces, that precipitation, that infiltration, that evaporation, or that surface runoff. As I mentioned, the water cycle will kind of move continuously forever and ever, basically, without any interference from people. But as I mentioned before, land use and human interference has happened to different parts of the water cycle. And this graphic kind of shows how the water cycle changes based upon the amount of development, and in particular, impervious surfaces get built up in an area. So impervious surfaces are those surfaces that do not allow water to flow through it. So I'm talking concrete, asphalt, even compacted soils and yards and other landscapes can actually hinder water flow. And so what we have here are these 4 different graphics that show increasing amount impervious surfaces going from the upper left, which has basically natural ground cover and no impervious surfaces, to the bottom right, which has complete build out. Think of a downtown metropolitan area or an urban area, 75 to 100% impervious surfaces, mostly asphalt, mostly concrete, lots of glass, lots of buildings, etc. And the different parts of the water cycle get affected by this increasing amount of impervious surfaces, and that's represented by the different blue arrows that are shown in each of the graphics. So in the upper left, say you have rainfall occur, these are the different proportions of that rainfall that would go to the different components of the water cycle. So 40% will go to the evaporation, the evapotranspiration, which is the movement of water. Transpiration is the movement of water through plants, and then the evaporation portion is just the heating up of water back to the atmosphere. So they combine those together. So 40% of the rainfall goes to that, back to the atmosphere. 50% goes to shallow and deep infiltration combined together. So that's what gets infiltrated back into the ground. But only 10% becomes runoff because the other components are kind of absorbing the water either in the soil or back to the atmosphere or through the plants. So you can see how I mentioned before, different factors in terms of soil type and the amount of vegetation that you have can affect the different rates here. But then if you go to the bottom right of this graphic, you can see the complete opposite end of the spectrum where you have almost no natural cover. You have 75 to 100% impervious surfaces. And now instead of 40% of the water getting evaporated or getting transpired through plants, you only have 30%. Could be because of the loss of trees. So you lose some of that transpiration portion, but only 30%. And instead of 50%, 50, getting back into the ground through infiltration, you only have 15%, 15, getting back in. So where does that water have to go? Well, it all moves to runoff at this point. So 55%, over half of the water, instead of getting absorbed back into the ground, becomes surface runoff and basically flooding. So it's got to be channeled to a detention basin. It's got to be channeled out of basements sometimes, but it's got to be moved out of the system to help get it to a place where it can get absorbed back into the ground. And rain gardens are one way that you can do something like that. So this is just a nice way to show different way that development can actually affect the different components of the water cycle and also increase the amount of runoff that's happening in an area as you build up an area. So just to kind of put it within context of the Barnegat Bay watershed, Barnegat Bay watershed is a nice large area. It's 660 square miles. It's 37 municipalities in Ocean and Monmouth counties. And looking at that impervious surface that I mentioned before, about 26% of the land use in Barnegat Bay watershed from 2012 data, which is the latest data that we have, is actually considered urban. So if you look at the map on the left, it's kind of those reddish pink areas are all our urban areas. So about 1/4 of the landscape within Barnegat Bay watershed is kind of built up in that way. So we do have some impervious surfaces within those, not fully 26%. It's roughly about 15% impervious surfaces that we have. So if we go back and look at what are some of the changes that we could see, most along the lines be in the upper right portion of this, where, you know, we drop the evaporation from 40 to 38%. We increase the runoff from 10 to 20%, and we lose that infiltration as well from 50% down to 42%. So you can see we're getting less water getting into the ground, more runoff happening, less evaporation. So you can see why flooding issues could be a potential problem because we have more runoff occurring. So almost twice as much in terms of this example here. But you can see also from this landscape too that there's a lot of potential for Barnegat Bay watershed because a lot of the areas are in more natural land uses. So we have a lot of forested areas, we have a lot of water and a lot of wetlands. So it's really important to preserve those areas. But say for those urban areas, we could put in things like rain gardens to help alleviate some of those water issues that I'm mentioning. So just to give you kind of a perspective of what's happening within Barnegat Bay watershed. Not only is it just the amount of water that's moving through the system, but it's also, you know, pollutants that are found in this water as well. So with these impervious surfaces, the pollutants will have a place to land on and build up on, you know, from atmospheric deposition, from any sort of land use practices or maintenance practices that we do on a landscape, especially in terms of like putting down fertilizers, pesticides, all that kind of stuff. So I refer to this slide as the alphabet soup of pollutants that can happen, but you can see that there's a lot of them that are in there. And, you know, there's no one solution that's going to deal with all of these, but bear in mind that it's not just a quantity of water that's moving through a system, but it's also the quality of that water. So whatever we do to the landscape in terms of, obviously fertilizing, pesticides, all that kind of stuff, illegal dumping, microplastics, etc., that can have an impact on the water quality as well and harm the wildlife that's out there, harm the vegetation, harm our soil structure, and eventually, cause degradation of our environment. So rain gardens are one way to help with dealing with some of this pollutants as well for certain ones. So I'll go into that in just a little bit. But then on top of that, with the water cycle, there's changes that occur due to climate change that's happening. So this whole slide basically could be an entire semester's course on climate change and water cycle. But just know that the climate changes that are happening that are driving, more drought systems, frequent flooding, melting of glaciers, increasing of sea level rise, that's all adding to different parts of that water cycle and causing those changes that you can see over the long term in terms of excessive flooding, drier conditions, not as much water getting back in the ground, etc. So you can see that there's all these different layers of things that can affect the water cycle, and rain gardens are one way to help alleviate this, if you're able to put one in the ground, literally and figuratively. So let's talk about rain gardens and why they're good and what they can be utilized for. So hopefully you guys have an inkling of what a rain garden is and have heard this before. But what I'd like to do is just talk to you guys a little bit about what a rain garden is and what it actually does. So a rain garden is, in technical terms, it's a landscape shallow depression that's designed to intercept, treat, and infiltrate stormwater. But basically just think of it as a mini detention basin that you put on a property. It can be at a home property or at a school. Hopefully it's at a school. That's why we're talking to you guys. That helps to reduce the amount of runoff that's coming off of primarily the building that you have. So usually we have rain gardens set up next to downspouts. They're collecting water off the roof. It'll get collected in the downspout. It'll go into the rain garden. It'll sit there for a little bit, get absorbed back into the ground, where it reduces the amount of runoff that's happening in the area. So the primary function of a rain garden is to reduce that quantity of water and reduce that volume moving through. So it's basically being used for flood reduction. But the plants in the soil that you have in a rain garden can actually help to alleviate some of the pollution issues that are there. So plants will thrive off some of the nutrients that are there, primarily nitrogen and phosphorus that gets added to certain landscapes. But then also the microbes that live in the soil can break down some of the other things that I showed you before in that alphabet soup of pollutants as well. So by allowing that water to kind of sit there and absorb back in the ground, what you're doing is you're reducing the amount that's coming off the landscape, whether it's the roof area of your house or the roof area of the school, and allowing it to soak back into the ground where the natural processes can kind of alleviate some of the problems that are there. And there's multiple processes that happen in a rain garden to actually do this. First and foremost, a rain garden helps to capture the water. A well-designed rain garden will have the water not stand there for more than 48 hours. Obviously, one of the concerns that people have is mosquitoes, so you don't want to have stagnant standing water there for a long period of time. That'll promote mosquito growth. So a well-designed rain garden that has proper drainage will capture the water and absorb it back in the ground in less than 48 hours. Ideally, you would want to do that in 24 hours, but you want to make sure that it's done by 48 hours, and that will help to reduce mosquito breeding in those areas. And so by having that water kind of captured for a minute, you're slowing it down and you're allowing it to soak into the ground. And not just soak into the ground, but soak into the plants that are there as well. So there are plants that really thrive in rain gardens, and I'll go into a little bit about plant selection in just a few slides. But the plants are hopefully well thought out and well picked to actually be within certain portions of the rain garden to actually absorb a lot of water, but also the stuff that's in that water as well, primarily the nutrients that'll help the plants thrive and grow and bloom. So that's one of the things that you can think of too, is that not just the plants are there for aesthetics, but they're there for a function as well too. Also, this helps to filter the water and reduce the pollutants in different capacities by having the water infiltrate and filter through the soil. So one of the things that's really great about a rain garden is that you're helping to get some water back into the ground, and you're reducing the volume that will go into a storm drain and it will actually extend the life of that storm system. So the storm drain, the stormwater system, and all the concrete pipes that are down there. So by having a rain garden, you can actually extend the life of the infrastructure that would normally carry a lot of the stormwater that would not get back into the ground. So I always liken the rain gardens as being kind of a giant sponge that you put on your property that will help to absorb and capture and hold on to water, but also some of the pollutants that are there through the plants and soil and the landscaping that you do there. So think of the rain gardens as just kind of like this big, well-designed natural sponge that you put out in a property and, hopefully on your schoolyard to help reduce the amount of water going through and also less runoff, creating less runoff and less water getting into the storm drain system, but also capturing some of those pollutants that might go downstream or not get treated if they didn't go through the rain garden itself. So how does your rain garden grow? How do you get a rain garden grow? Well, all these things need to go into a rain garden. So I always warn people that there's a lot involved in doing a rain garden. I would encourage people to do it if they have the ability to do it. That would be fantastic. But also think about all the things that go into it. So you have to basically know some hydrology, and you have to know something about the hydrologic cycle. I gave you a very brief introduction. You have to know a little bit about the pollution sources that are coming off it, whether it's non-point source pollution or another type. You have to know about wildlife habitat, the nutrient cycles. You have to know about soils and soil chemistry, a little bit about landscape design and architecture. You have to know the local ecology and all this stuff that gets added into it. So a rain garden is an engineered system that you can put on your school property, but also know that there's other things that need to go into it. And some of the resources I'll give you today will help you guide you through these different parts so that you can actually work your way through and actually get a rain garden on your property if you are so inclined. So even though there's a lot involved with it, it can be broken up step by step through different resources that we have that you can actually get one installed and put on your property. But the good thing about rain gardens is, since they have all that stuff that's part of it in terms of design, architecture, and ecology, they can be a variety of things. So it doesn't necessarily have to be just one size fits all for a rain garden. Rain gardens can be readily implemented throughout the communities, throughout schools, and it can also help to reestablish natural processes and primarily going back to a more natural way of having that water cycle move through an area. But a rain garden can be a butterfly habitat if you so choose to have butterfly-friendly pollinator plants. It can be shoehorned in along a sidewalk, so it can kind of be designed to fit into smaller spaces if you have a smaller space or not much green space on your school. It can include trees and shrubs. A lot of people think rain gardens are just the smaller flowering plants, but it can be trees and shrubs as well. They have been put in parking islands, so if you have a schoolyard that has a huge parking area and you have parking islands within it, they can be put in there as well and collect some of the water off the parking lots. It can be a wet meadow. You can have them designed to hold on to the water a little bit longer with more wetland loving plants. It can be a perennial garden. It can be something that's designed to provide some sort of aesthetics throughout the year. So you just don't see them kind of blooming within that April through October timeframe when the majority of schools are actually closed for the summer. But the kids can actually see it, and the school community can actually enjoy it while it's in full bloom throughout the year, and not just during the height of summer when most schools are closed. So rain gardens can fit a variety of needs, whether you're promoting wildlife habitat or helping to reduce pollutants, but it can have multiple functions if designed properly, and actually going through the step-by-step process of determining whether or not you need a rain garden and what you want to do with it. So just to go through the different parts of rain garden and talk a little bit about design and what you can actually do to actually move forward with a rain garden. So there are multiple parts. As I mentioned before, we usually have a rain garden be next to some sort of water source, and generally that's a roof and the runoff from the roof and next to a downspout. So that's our inlet on the left side of this slide. You do have to have a good solid planting medium. So if you have soils that might not be the best for putting in plants, you may have to do some sort of soil amendment by adding sand, especially for infiltration, because the main point of a rain garden is to absorb the water back into the ground. But because it's also a shallow depression, you're going to have kind of different zones where plants can grow and where water will stay. So the bottom area of your rain garden is going to be your ponding area. you are going to have a berm and a buffer around it. So think of kind of a heightened area to kind of act as a bowl to hold onto the water as it goes in from your source, whether it's your roof or downspout or whatever it happens to be. But you have to have kind of like this bowl-shaped area to hold on to the water. And the size of your rain garden will depend on the size of the area being drained from a roof and how many downspouts you put into it. So obviously, the more downspouts you put in, the bigger your rain garden. In general, a rough estimate is for each downspout, it's about, think of the size of a rain garden to be about 10% of your total roof area. Okay, for each of the downspouts that you're going to put in. So if you're going to put in 2 or 3 downspouts, say you put in 2, you want to think of 20% of your roof area will be the size of the rain garden. So if you have a roof area that's 1,000 square feet and you have 1 downspout, roughly about a 100 square foot rain garden would fill your needs for that. But there are ways for you to actually calculate those numbers so you actually have the right size rain garden for the drainage area that you're trying to collect from. Obviously, that would change if you're thinking about using a parking lot or a parking island as well. You need to figure out the size of the parking area that drains to it. So in terms of a rain garden, thinking about where to put a rain garden, if you're thinking about doing one, these are some general things that you want to avoid and where you want to cite them. They're primarily listed for residential areas, but these rules will follow you guys as well. You can put a rain garden next to a building, but if that building has a basement or the area you want to put in it has a sub floor next to it, you don't want to put it within 10 feet of the building because obviously it's going to be holding on to water and getting it back into the ground. We don't want to flood out a basement or flood out a sub level. But if there's no basement on that building and you want to put it next to it, you can do it within 2 feet, no closer than 2 feet of the building. So, 2 feet or further away. Whereas if you had a basement, you don't want it within 10 feet. Obviously, if you have some sort of septic system or any sort of utilities that are there, so that's the last bullet, the underground utilities of irrigation lines, phone cable wires, other sort of underground piping that you might have or wiring that you might have, you don't want to place a rain garden in those areas. Obviously, it's like the situation where you have to call before you dig so you know where those utilities are. But if you do have some sort of septic system on site, you don't want to have a rain garden within 20 feet of that. You don't want to site a rain garden in a soggy area where water is already ponding up. And this is the one that kind of people are like, oh, I would have thought that's a great place to put in a rain garden. If you have a part of your property on a school that you already have water ponding, that's a much larger engineering issue and a larger soil issue that a rain garden is not going to fix. For example, you could have a lot of clay in your soil that is preventing the water from getting absorbed into the ground because clay acts as a physical barrier to prevent water from getting absorbed. So if you dig out a little bit of that clay and put in sand and put in plants, the water's still not going to go anywhere because it's just going to sit in that rain garden because it can't flow through the clay that's in the soil. So you want to know a little bit about the area before you put a rain garden in. So if you have an area where water is already ponding, it may not be the best spot to put in a rain garden because you're not going to get the drainage that you need to absorb that water back into the ground. You want to avoid the high water table. You don't want the bottom of your rain garden to be within 2 feet of that. So you need the water table to be 2 feet below the bottom of your rain garden. And you can kind of test out and do some online searches to figure out where the water table is in your area. There's some groundwater resources that are available. One of the things we recommend to people is to consider flat areas first. They're actually easier to dig out. So you don't want to hit something that's too much of a slope, something that's too hilly or too wavy or bumpy. It's a little bit more difficult to dig those out. You also want to avoid placing a rain garden within the drip line of a tree. And the drip line is basically how far out the branches and leaves of a tree go out to. So the drip line zone will actually have the water get collected by the tree and it won't allow enough water to trickle down to below where the bottom of the tree is and fill up the rain garden. So you'd actually be losing some water from that. It's not the best situation to be in. But one of the things to bear in mind is to provide adequate space for a rain garden. I always tell people it's better to oversize your rain garden rather than undersize your rain garden. So that 10% that I mentioned before, you might want to think of something larger. So if you have a 1,000 square foot roof and the recommendation is a 100 square foot rain garden, you might want to think about a 150 or 200 foot square garden if you have the space to do it and the time and resources to be able to do that. I'd rather have a larger rain garden that is providing better function rather than having an undersized rain garden, but make sure you're getting the right size at a minimum, but provide adequate space for that rain garden. And I mentioned the underground utilities as well too. So you kind of have in your head that you want to do a rain garden. you kind of know where you want to put the rain garden. You found a good site. You kind of understand the parts of the rain garden, but the parts of the rain garden come really into play when you're talking about plant succession. And the success of a rain garden really depends on selecting the right plants. So this is the right plants for the right place. Here we have an example that you can kind of plug into most of the Barnegat Bay watershed, dry sandy soil rain garden. Obviously, make sure you know what kind of soil type you have before you start putting in a rain garden as well. And this is kind of just a planting template that you can utilize. It's actually color coded by the color of the plants, of the flowers, excuse me, as they grow and mature. So you can kind of get a sense as to, where you can put in a rain garden and what kind of plants can you put in. Native plants are the best to put in because they are adapted to local soil and climate conditions, but also native plants are less resource intensive than non-native plants. And obviously, if you want to do something like a butterfly habitat, you want to have the native pollinating plants that they'll actually go to for the local species as well. I always tell people that rain gardens are not no maintenance systems, they're low maintenance systems. So there is some maintenance that needs to happen, but you don't have to do as much regular mowing or watering of these systems. And you can actually save some water, especially if you're replacing turf grass, because turf grass is a very thirsty plant. You can save about 55 gallons per square foot annually if you're replacing turf grass with native plants, but also with a rain garden as well. So you're going to be using less fertilizers, less pesticides, less mowing, so there's less air pollution from the mowers. There's less watering, so there's less use of the water resources. So all those things I mentioned before in terms of improving water quality and reducing your water use can happen through, using native plants within the rain garden itself. So, but if you're planning on moving forward with the rain garden, I would definitely say use native plants to help with your long-term maintenance. So where can you actually put the plants? What's going to help you decide what plants to put in? Well, the actual shape and depth of the rain garden itself will help you to determine where you can put plants. So there are three main zones of the depression part of the rain garden, and that's the buffer, the slope, and the base. So the base is where you're going to have most of your water. So you want to make sure that the plants that you put in that are planted within the base area are going to, be able to handle those wetter conditions and have what we like to call they have wet feet. So which means their root systems really enjoy and their growth forms really enjoy wetter soil conditions. So they prefer higher soil moisture. So as you move further away from the base and kind of move outward to the slope area, it's going to be a little bit drier. And then you're going to hit the buffer, which is going to be the driest portion as well. So not only just knowing, oh, I want to use native plants, what kind of soil do we have, but also knowing your soil moisture and how much water is going to be there will help you to decide what plants to put in that area. So the buffer area will be the plants that are a little bit used to drier soil conditions, drier growth forms. As you go to the slope, there are ones that are kind of like Goldilocks, not too much, not too little, not too hot, not too cold, not too dry, not too wet. So you're going to put those in the slope area, but those that are in the base are going to be the ones that really love the wetter conditions. Traditionally, we've used things like blue flag iris in some of those areas, especially the ones that are right next to where the water's coming in, because that generally gets a lot more of the water into it. So you also want to be able to know where your water is coming from and where it's going out. So where your water is coming in, that's going to be your wettest soil condition. So even on the base, on the top part of this slide, you can see the inlet. That's going to be your wettest point, and then out from there is going to be the ones that get a little bit less moisture within them. So you have to be aware of the soil moisture as well and know what you're looking at there. So these are just some templates of different things that you can do with some of the plants. You can put in plants that are, as I mentioned before, butterfly friendly. So you have pollinator plants. An example of one for the rain garden is planting, and it goes by the different colors of the flowers. There's butterfly milkweed, Indian grass, goldenrod, Joe pieweed, purple coneflower, switchgrass, New England aster, and sweet pepper bush, which are all native plants, which are great for butterflies to utilize. But on the left-hand side, you can also think about, the rain garden, if you put it in a school, is going to be seen year-round. And not just when it's flowering in the height of summer, because the school is going to be closed and hopefully the students are back home. But you can see that you can do it with it's got ornamental bark, ornamental berries at different parts of the year. So you can have the design and the choice of your plants be something that's kind of blooming or have some sort of visual interest throughout the year. So it's not just, at the height of their bloom season from April through October and for New Jersey, but also, do they have pretty stems that'll look, nice in the wintertime, in the fall when the leaves are off the plant? Do they have nice berries or fruits that are on them, at the beginning of the spring when more students will be able to see it? So those are the things that you want to think of as well when you're picking out the plants for your rain garden. So what native plants to use? It's difficult for me to sit here and say, here are the ones that you need to do, obviously, because site by site they vary, but there's a great resource. And since, we are doing this as part of Jersey Friendly Yards, is to utilize the Jersey Friendly Yards plant database. It brings together lots of different resources for you to utilize to find out more information on rain gardens, but also to pick the plants for your particular area, your particular site. So if you go to the Jersey Friendly Plant Database, you can put in all the different conditions that are at your site. You can, to pick a certain region. You can pick what type of plant you're looking for, whether it's just ground covers or grasses or trees or shrubs. You can decide to do just native plants. You can look for things based upon their bloom color, their soil type, how much sun they need, etc. It's a really great resource that you can go through. And I believe they may have introduced it in the first week of this series, but they do have an online video tutorial. It's about 3 or 4 minutes long to kind of walk you through the way to use this database. And it's a fantastic resource. But if you also know what plants you're looking for, you can just do the find a specific plant as well. But it's a really, really great way for you to think about the different soil moisture, the sunlight that you would need at a particular spot, especially if you're going to put in a rain garden. So to talk about rain garden installation, the big thing I want to say on this is be ready, be sure you're ready for all of this if you want to do a rain garden. It involves, obviously before you install, you have to go through siting and design and picking the plants and making sure it's sized right, etc. But you have to go through and remove the existing grass in the area. You have to excavate to the desired elevation and grade. You have to add soil amendments if necessary. You have to prepare a berm if necessary. You have to prepare an overflow. So if you have water coming in, you want to make sure the water overflows to somewhere else, because the rain garden itself won't handle all the water coming through. It'll just handle a portion of it. So do you have it overflow to a storm drain? Do you have it overflow to another area? You want to make sure that you level out the base, which is that lowest area. Plant the native plants, apply mulch, water plants. And then the 10th step that should be part of this as well is maintenance. You have to maintain it. There is some weeding that would be involved. You may have to replace some plants. Always make sure that if you go for a grant or have a budget for this, that you budget in maintenance costs. Work with your school's facilities or grounds crew. Make sure that they know what's going on, because they can help with that as well. And they're a great resource to add to that tip. I just want to give you guys a quick example of a rain garden that's on a school property, but it's on a university property. So we did, in partnership with Georgian Court University, we planned out a rain garden with them to help reduce nitrogen from getting off their property. And so we picked a site that was next to their dining hall. And I've shown you all these great photos of these nice curving rain gardens, being kidney bean shaped. We did a rectangle because of the site that we were working in. It was most conducive, just kind of hedge it in between two buildings and put in this rain garden. But we put in New England aster, false blue indigo, creek sedge, tufted hairgrass, golden aster, blue flag iris, goldenrod. And one of the things that went into the choices for the plants were, where they would be within the rain garden. Also, the amount of deer resistance they have, because they have a deer population problem on Georgian Court University. But also, we tied it into the school colors of Georgian Court University. Georgian Court University's school colors are blue and gold. So we tied in the flowering plants to reflect the colors of their school. So if you are thinking of doing a rain garden on your property, on your school property, if you incorporate the school colors, it goes a long way to help with the administration. So it also gives you a little bit of source of pride, especially if you put that rain garden in an area that's visible to a lot of people, and especially a lot of the students, a lot of the people, the teachers who work at the school and the administration. If they see it all the time, they see the school colors incorporated within it, it'll go a long way to selling the rain garden. That's my little tip for you guys. So if you incorporate that into it, you can kind of bring that choice in as well. Obviously, native plants and the right plant for the right place, but hopefully you can get some colors to match your school colors. Because this rain garden was designed to deal with nutrient pollution, primarily nitrogen. Unlike most rain gardens, it wasn't, we didn't allow it to infiltrate into the local soil. We actually piped it and barricaded it with a plastic pond liner, which you can see in the top photo, put in some piping to help deal with the overflow, and then filled it with gravel and filled it with pea stone, and then put a planting medium on top of soil, and then planted within that. So this was it before planting, and this is about a year and a half after it. It had been able to thrive and collect water off of the dining hall roof. We actually monitored the water to see how well it was doing, and it did a pretty good job in reducing a lot of the nitrogen before it actually got into the storm drain system. So it was really great way for us to utilize a rain garden to help reduce some of the pollution that's coming off their roof runoff. And these are just some of the pretty pictures of some of the plants that went into it. So we have blue flag iris on the upper left. We've got the New England aster on the bottom left. And on the right, we've got the blue lobelia as well. So you can see those blues and purples that really kind of match the blue portion of Georgian Court University's color scheme. But then we also had a lot of yellow through some of the goldenrod. Goldenrod's great for butterflies and can attract a lot of pollinators. So you can actually have it provide a wildlife habitat as well. So people can actually see from the dining hall some of the native pollinators, some of the native wildlife that can actually collect in an area and visit this. So they can actually get that added benefit as well. But you guys are probably here for the resources for New Jersey and rain garden resources. There are some great resources that are out there, some that are pretty generic for rain gardens, some that are really designed for the homeowner, but really can help with the schools as well. The first one I'll point you to is JerseyFriendlyYards rain garden page. How to actually create a Jersey-Friendly Yards can be through rain gardens. Lots of resources there to follow up on. I will be making this presentation available to the people who registered, so you can have it available, and I'll also make sure that Becky gets a copy of it. So if there's any questions, if people want to follow through with these resources, that can be arranged. In addition, there's also Rutgers Cooperative Extension Water Resources Programs Rain Garden Manual. This is really geared towards the homeowner, but it takes you step by step by step from the thinking about doing a rain garden all the way to the installation and maintenance side of it. So it takes you through that whole process so you can see what it really entails in designing and developing and siting your rain garden. But since you guys are schools, you might be more interested in the stormwater management in your schoolyard, which is also through the Rutgers Cooperative Extension Water Resources Program. This is a guidance that takes you through learning modules, so your kids can learn about watersheds and water pollution and what a rain garden is and how plants function, etc. So this is a great resource. It's got videos, it's got lesson plans, it's got lesson plans for K through 3, 4 through 6, 4 through 8, and then high school as well. So all different ages and all different ranges. Some of the resources include some of the curriculum criteria that you guys would need to meet as well, so you can match up the different lessons to the different criteria you need to teach throughout a given year. And then there's also the information on just the Water Resources Program's Rain Garden webpage. They've got a whole host of resources as well. I think this page might be linked within the Jersey Friendly Yards one as well. So if you go to the Jersey Friendly Yards page, you'll see these as well. So to get you started with doing any sort of work in your schoolyard. But the big one that you guys would probably be interested in, and I can make this available to those people who registered, is the Rain Garden Handbook for New Jersey Student Education. This includes lesson plans. These also go to the state curriculum criteria. This was put together through the Rutgers Cooperative Extension, but also with funding from the New Jersey Water Resources Research Institute. This came out a few years ago, but the information in it is still up to date. And it provides a lot of information as to what you would need to do to actually do a rain garden at a school. So it goes through the different parts as well. So using this in conjunction with the stormwater management in your schoolyard and also the stormwater management, rain garden manual of New Jersey will be resources that you guys can utilize to actually go from start to finish in your rain garden, from deciding on doing it, moving forward, designing, siting, all that kind of stuff until you get to the end where you're getting to installation and maintenance. So one of the other resources that's available is, if you're thinking about doing a rain garden, there's a rain garden design form, and I can make this available to you guys as well. It basically goes through the different checklists of what kind of site you have and where you are thinking about doing a rain garden. My favorite part of this is the first question to ask you is, what amount of time do you have to put towards maintaining your rain garden? If you have a lot of time, you can say, oh, I've got about 6 hours a month I can put in this. Then it's going to be, a different kind of rain garden you'll design. But if it's low, you might want to think of an easier to maintain system, in terms of a rain garden, how big you're going to make it and what you're going to do with it. So that's my favorite part about this, is that's the first question to ask you. But it also asks how big you want the rain garden to be. So you're going to have to figure out through the rain garden manual of New Jersey how you can, size that properly. What kind of sun, soil, drainage, and slope conditions do you have? And also, how much of your property is impervious surfaces? These are all just good estimates you can do. What is drainage area of the proposed site? Like, is it going to be from a roof, from a parking lot? Does it have a basement, or sub level? What would you prefer in terms of the plants and irrigation that's available and stuff? So this can kind of help you kind of like answer those initial questions about what you think you want your rain garden to actually look like at the end when you go through it. So that's kind of my spiel. What I would like to do actually is, if I have a minute or two, is just to kind of pop open that school rain garden handbook that I showed you before, just to kind of walk you through it. I can make a PDF available. I will warn you, it's about 250 pages, but it does have like lesson plans within it and other resources that you guys can use to get a rain garden on your site. So I could just go ahead and pop that. So I stop sharing this. And I'm going to share something else. So this is that rain garden handbook. It's 256 pages. I will say that the one downside to this PDF is that there's no table of contents, unfortunately. So you do have to kind of scroll through it to see what's available. But it does have within it a background, who it's designed for in terms of grade and age level. They do have all the different lesson plans within it that can be utilized. It does have learning goals. It does go through an outline of an introduction to watersheds, and provides you information on how to it provides you lesson plans, excuse me, on how to teach that to students and what they can get out of it. So there's all sorts of information that's within this. It's a great resource. It's available through, I believe, the Water Resources Program's Rain Garden information site. But if not, I can also make this available for you guys as well too. But it's really designed for educators to utilize to actually start the ball rolling of educating people about rain gardens, educating your students about rain gardens, and then you can use the other materials in terms of the handbooks to design and move forward with a rain garden as well. So that's what I have for you guys. I can make this stuff available for you afterwards, but thank you guys so much for your time and attention today. I really appreciate you guys being here, especially on such a nice day. But it's fantastic. But thank you everybody for being here, and I hope you got something out of this.
Thank you very much, Steve, for that amazing program. Such in-depth information that you shared and wonderful resources. I can't wait to get my hands on that last 200 plus page resource and thumb through it. So can't thank you enough.
Thank you.